हेलो दोस्तों, आज हम लोग आइसोमेरिज्म जो दूसरा टॉपिक है ऑर्गेनिक केमिस्ट्री में उसको शुरुआत करेंगे। आइसोमेरिज्म के बारे में कहता है कि दोज कंपाउंड्स which have same molecular formula but different structure, and properties are called isomers, and the phenomenon is called isomerism. For example, हम लोग नॉर्मल ब्यूटेन लिखें और सेम नंबर ऑफ हाइड्रोजन और कार्बन को यूज करके हम लोग आइसोब्यूटेन लिखें। दिस इज एन ब्यूटेन, दिस इज आइसोब्यूटेन। तो ये दोनों का जो मॉलिक्यूलर फार्मूला है, मतलब नंबर ऑफ कार्बन और हाइड्रोजन दोनों का सेम है, लेकिन दोनों का स्ट्रक्चर अलग है और दोनों का प्रॉपर्टीज अलग है। तो ये दोनों आपस में कहेंगे कि ये दोनों आइसोमर्स हैं। आइसोमर्स दो टाइप के होते हैं। एक स्ट्रक्चरल आइसोमर्स और दूसरा स्टीरियो आइसोमर्स। स्ट्रक्चरल आइसोमर्स, दूसरा स्टीरियो आइसोमर्स। स्ट्रक्चरल आइसोमर्स 2 डायमेंशनल चेंज के वजह से होता है, स्टीरियो आइसोमर्स 3 डायमेंशनल चेंज के वजह से होता है। स्ट्रक्चरल आइसोमर्स में नॉर्मली बॉन्डिंग का चेंज होता है। चेंज इन bonding. Here there will be change in arrangement. Now structural आइसोमर्स के अंतर्गत हम लोग अलग अलग टाइप के आइसोमर्स पढ़ते हैं, जैसे चेन आइसोमर्स, पोजीशन आइसोमर्स, फंक्शनल आइसोमर्स, मेटामर्स, टाउटामर, रिंग चेन आइसोमर्स, एक्सेट्रा। सिमिलरली स्टीरियो आइसोमर्स में दो टाइप का आइसोमर्स होगा। एक है configurational आइसोमर्स और एक है कन्फॉर्मेशनल आइसोमर्स। इस कन्फिगरेशनल आइसोमर में और कन्फॉर्मेशनल आइसोमर्स में एक ही टाइप का बनेगा कन्फॉर्मर्स, और कन्फिगरेशनल का दो भाग, एक ज्योमेट्रिकल आइसोमर्स और दूसरा ऑप्टिकल आइसोमर्स। ज्योमेट्रिकल आइसोमर्स एंड ऑप्टिकल आइसोमर्स। तो इतने तरह का आइसोमर्स हमें ऑर्गेनिक केमिस्ट्री के अंदर पढ़ना होगा। हम लोग शुरुआत करेंगे स्ट्रक्चरल आइसोमर्स से। स्ट्रक्चरल आइसोमर्स और स्ट्रक्चरल आइसोमर्स is also called constitutional isomers. Constitutional isomers. इस स्ट्रक्चरल आइसोमर्स का जो पहला टाइप का आइसोमर्स है वो है चेन आइसोमर। चेन आइसोमर्स क्या होंगे? दिस इज also known by the name of nuclear isomers. This isomers arises due to change of main chain of any organic compound. So by definition we can define it कि compounds which have same molecular formula but have different properties due to change in chain are called chain isomers, and the phenomena is called chain isomerism. Phenomena will be called chain isomerism. So what is important in chain isomers is, if two compounds are chain isomers, then while naming them, root word of compound must change. So here important point to remember is there will be change of root word in names of compounds which are chain isomers, and this is obvious. A change of root word is because there will be change in chain meaning that is number of carbon in main chain. So easiest way to identify which two compounds are chain isomers is the change of root word. For example, we have a compound CH3, CH2, CH2, CH3 and other compound CH3, CH, CH3 and CH3. If we try to write the IUPAC name of these two compounds, then this compound is butane, so root word is but, and this compound is 1, 2, 3. We have already covered nomenclature. So there is a substituent and position number 2, so its name is 2-methyl propane. So here root word is prop, here root word is but. There will be a change of root word, so these are chain isomers. So one thing to remember, when we look for the change of root word, the change of root word must be seen based on IUPAC nomenclature, not on the basis of common nomenclature. So we have to look for the change of root word based on International Union of Pure and Applied Chemistry's convention given for nomenclature. Then the second type of structural isomer is position isomer. Position isomers. So position isomers is the isomers which arises due to change in position of either substituent or functional group in any compound. So isomers which arises due to change in position of either substituent or functional group. Groups in any compound. Then this will lead to position isomers. Easiest way to identify position isomers is there will be change in locant value of substituent or functional group. If there will be change of locant value of substituent or functional group, then the type of isomers we obtain will be called position isomers. For example, we have a compound CH3, CH2, CH2, Cl, 1, 2, 3. It will be called 1-chloropropane. So 1 is the locant value of chlorine here. Similarly, we can have a compound with similar molecular formula like this. Then the name of this compound will be 2-chloropropane. See, the root word is same, propane, but the locant value of chlorine is 1, here 2. So there will be change of locant value. And if locant value of substituent is changing, then it will be position isomers. Then the third type of isomer in a structural case is functional isomers. So what is functional isomers? In the isomers which are arising because of change in functional group without change of molecular formula, then the isomers will be called functional isomers. So isomers which arise due to change in functional group, change in functional groups are called functional isomers. So there is a comprehensive list of functional isomers which functional group can change into which other functional group are as follow. Like if we have alcohol, then it can change into ether. If we have aldehyde, then it can change into ketone. If we have carboxylic acid, it can change into ester. If we have cyanide, it can change into isocyanide. If we have nitro, then it can change into nitrite. If we have diene, it can change into ine. There will be change of 1 to 2 to 3 degree amines. Similarly, 1 degree, 2 degree, 3 degree amides. Amides means acid amide. Then amide can also change into oxime, nitroso. Then there will be case in which aliphatic compounds may change into aromatic compounds. So these are the possible change of functional group leading to functional isomers. So let us look at examples of each of these possible changes in functional group. So first is alcohol to ether. Let's take example. Let's say we have propane, 1-ol, and the corresponding ester can be methoxyethane. If we look at these two compounds, we have two separate functional groups. One is alcohol, one is ether. So there will be change of functional group, but molecular formula is same. So these are examples of functional isomers. The second case is aldehyde may change into ketone. For this purpose, we must remember aldehyde must be of at least 3 carbon. So example is propanol. It can have the structure of ketone. This is propanone. The same molecular formula, but here we have aldehyde functional group, here we have ketone functional group, change of functional group. These are functional isomers. Then third possible conversion is carboxylic acid to ester. So we take examples of a carboxylic acid. This is propanoic acid. With same molecular formula, we can have a compound called methyl ethanoate. So in these two cases, one is acid functional group, one is ester functional group, same molecular formula, change of functional group. So these are functional isomers. Then next possible change is cyanide to isocyanide. This is very simple. Cyanide to isocyanide. Ethane nitrile, and we can have methyl isocyanide. So these are change of functional group. So these are functional isomers. Then we have nitro and nitrito. So this is again simple. Nitroethane, CH3, CH2, ONO. So nitro group, nitrito group, these are functional isomers. Number 6.